All right, so we're going to keep talking about estimating areas using rectangles, but I want to show you some word problems that we will have a nice application for these estimates. So get yourself ready for notes, and we're going to get started talking about rate tables and graphs. So here we are, and it says you note the speed of your car over time at the table on your left. Approximate your total distance traveled using left endpoints. And so here, this is where the nice fact is that the area under a rate function. So a rate function is something per blank, right? So in this case, miles per hour. But if you have a unit like that as a function in a table like this, the area under that curve is equal to the amount, you can think of as finished, produced, completed, in this case traveled, if it's a speed. All of these things are, as long as you have a rate function, you can find, all right, if I know the rate that a machine was making pasta, I can say how many pounds of pasta were made in this time frame if I know the rate at which the machine is working. Same thing here. If I know the speed the car is going, I can estimate the total distance traveled by finding the area under that function. Now, just like in our last lesson, I think it's easiest to start by drawing out, let's try to make that a little bit darker, drawing out a basic table of the data. And that's going to help you figure out for number 2, you can see it's asking, is this an upper estimate, an underestimate, or an overestimate? It's just easier if you start out with a table here. I'm looking at my speed, which I'll put on my y-axis. I notice my top speed is 32, so I'm just going to make my top one here 40 because that's easy to divide like this. And then my time is 20, 10, 5, 15 for time. So now I have a basic graph. I'm going to plot these points. So at time, when I first looked down at the speedometer, it said it was 17. So 17 would go about here for time 0. Time 5 is 21. Time at 12, which is about here, is 24. 15 is 32. And 20 is 31. So I'm making this basic curve. Now, we don't know exactly what's happening. You could sketch in a curve if you like. But we're going to estimate using left hand. So I'm going to draw my heights of my rectangles down. And then, since it's left, I'm going to start here and then draw from the left. Left, 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 and then draw a little bit down there. So these are the rectangles I am going to use using left endpoints to approximate my distance traveled. Now in this case, you'll notice that your heights and your bases are going to be different. So unlike the last set of problems, here my base is 5. Here this is from 5 to 12, so that base is 7. This base here is from 12 to 15, which is 3. And we have another base of 5. So in this case, I'm going to write them all separately. My area for the first one is base of 5. And then the height here is 17 plus base of 7 times the height, which is 21, plus 3 times 24 plus 5 times 32. So in this case, it's probably going to be a lot easier just to type this in on your calculator, though of course you can multiply by hand. So this would be equal to 464, and I can use here, we've got time in minutes and miles per hour, so if you want to include the units, time, as it says, is in minutes. So you're multiplying minutes times speed, which is miles per hour. I want to cancel out minutes and hours. So if I want to then say convert using, so we've got, let's see, minutes over 1 times miles over hours, and then cancel out minutes in the denominator with 60, 1 hour. So if I wanted to find this in miles, I would divide 464 by 60, which again, you can absolutely do by hand, but you can also pick up your calculator and get that 464 divided by 60 is equal to 7.733 miles. And again, just an estimate, but it's a nice way to figure that out. Now, would you hypothesize that this is an underestimate or an overestimate? So what I would do here is I am not going to sketch in a curve, but I'm going to say, all right, well, I'm probably looking at speed like this, just connecting those points. I don't even need to do it as a curve. I can make segments, make it a line graph like this, and I would suppose that I have underestimated here, because I'm not counting these areas, and then I would have an overestimate just on this last rectangle. So since the first 3 sections, so the first, in this case, 3 quarters are underestimates, and just the last one is an overestimate, I would guess that this is an underestimate based on the data here. If you have questions on anything that you, about tables, about anything from 5.1, please make sure that you're nominating things in the forms attached, and let me know anything else in the comments, and be sure to check your email for those responses. I'll talk to you